Hi everyone, welcome to my basic Fire tutorial series. My name is Arat Panjawat. This video series was created for the master program in data science for healthcare and clinical informatics at Ramatibadi Hospital, Mahidol University. Now we are in the module 3, Fire Conformance. And here is about me, and you can reach me on this channel. The agenda of module 3 is like this. We will begin with how we can working with terminology in Fire. Then we will talk about how to create an extension. And the last one is profiling. So let's start with how to work with terminology in Fire. In this part, I will begin with some recap about Fire and terminology in general. And then we will talk about three risks, and then we will talk about three important resources when you're dealing with terminology in Fire, that is code system, value set, and concept map. And I will have demo on each resource. Before we begin, I would like to recommend you, if you're interested in this topic, I recommend this video series from Ahin, Seal Asia, and from Cicero from Australia. It's an on-the server training series. These video series are very great training about terminology in general and Fire terminology. And many of the knowledge I use in this session also come from this video series. If you want to learn more about this concept, please check this out. To recap a bit about terminology and Fire, the goal of interoperability is structural and semantic interoperability, right? And to achieve this goal, we need several standards, and we can group it into three groups. Lower level standards is like a ground that a tree can grow. This one is a technical thing. Content standards is like a trunk, a branch that grow from a ground. I consider Fire as a content standard. It has a shape of tree, but it cannot be a complete tree without a terminology standard. So we need terminology standards like SNOMED CT or ICD-10, LOI, or other many terminology standards to make to achieve a structural and semantic interoperability. And how we can use terminology. I have to disclaim that this slide I was adapted from Dr. Jim Steele from the talk that I mentioned earlier. So we can use terminology in many situations, like let's say data entry. Let's say that we have a healthcare system that we have to input the data inside that quickly, but we don't in charge for the core system ourselves. Let's say that there are some organization or some government in charge of maintenance that core system in another remote server, remote repository, and we have to quickly query from that repository into our system. And we have to make sure that the code that we put in the system is the right one. The second use is validation, to validate that the code you have is it correct or not. The third one is display. Let's say you have a code and you want more information about that code. So you ask the server, oh, what does this code is about? And what is the relationship with other codes? Mapping, you have a code from this particular system. What is the code of another system? So you ask the server, oh, what is the code of another system? Analytics, you have a coded data in your repository and you want to maybe categorize it to some way and do some analysis stuff to find some insight knowledge. Authoring, let's say you want to create a code system or value set on your own. The last use case is server, like to make a server smarter, like you want to query a condition resource with a particular code, and not only that code, but all conditions that are the children of that code For example, we can use Fire to facilitate all of this functionality. Like we have a terminology server, and then we use Fire for terminology service, and we communicate with the application via Fire interface. For example, terminology binding. Let's say we have a resource, maybe a patient resource. In that resource, we will have a lot of elements, right? And each element will have data type, but there will be some element that have some data type that related to coded data, and there are 3 data types that deal with the coded data. This element will bind to a particular value set. Some was defined by Fire, some we can design by ourselves. The flexibility of the code that we can use come from the binding string between that element and that value set. There are 3 Fire coded data type, right? The first one is code. This is a primitive type that we insert only code, such as patient.gender. We choose the value from male, female, other, unknown. Coding is a code and a system, so that we can know what code system that this code came from, such as encounter class. The code is from this code system. Codable concept is a group of multiple coding into one element. Is multiple coding that share the same meaning. Maybe the element use the code from Sonoma CT for one code and use another code from ICD-10 that are the same disease, for example. Here is the structure. Code is the just one value. Coding is like this. It's a code and a system and other data. And codable concept is coding in array like this. So this is code. This is coding. This is the name of the element, and this is the structure. This is the name of the element, and this is the structure of codable concept. There is an element named coding, and inside there are multiple coding data type inside that. And this is binding string. Is the degree of flexibility that we have between the element and the value set. If it's required, the concept in that element must be from the value set that is required. If it's extensible, they want us to use from that value set. But if it's not cover the concept that we want to use, then we can use alternative coding. Prefer is like they want us to use, but not require. We can use that if we want. Example is just like a example. We can use or not. It's totally up to us. And all of this is about data type. The next recap is about terminology resources. In this module, in Fire specification, this one, we have terminology module that deal with terminology things. There are many resources in this module, but I would say the important one is these 3 resources. The code system is a resource to define the code system. How many codes are in that system, and what are those codes? Our value set is like a select sum of the code from the code system to form a set of value. That's why it's called value set. And we will bind the element, the definition with the value set. This one, you may feel confused about it. What I want to say is we have code system and the value set select from code system. And in case that we have 2 value set and we want to know which concept in the source value set can map to another concept in another value set, we use concept map for that. These 3 is the important terminology resource set. Let's say we have code system A and we have 6 terms inside, and we have code system B that have 5 terms inside. We can create a value set that have maybe 2 terms from this code and 1 term from this, or we can create a value set that only have term from this value set. It depends on us. So if we have the relationship between these 3 is like this, we select some concepts to form the value set A, and select some from code system C to form value set B. Maybe this one and this term and this term can map to this term, and no code in this value set can map to this term. For example, we use concept map to explain mapping between the source and the target. In Fire, and they have many code system and value set already defined. Some are defined by Fire itself. Internal Fire and external Fire are also Fire, different at the URI. And they also include from HL7, V3, and V2. And there are also a way to reference to external code system. And this page for the list of value set already defined in Fire. Okay, if you came here and you came here, I think it's here. Yeah, this one is the list of code system that already registered with Fire. This is external system like SNOMED, LOIN, RxNorm, UCUM. This one internal, external. This from V2, V3, this from V2. And this value set already defined. And I mentioned briefly about this terminology service in this slide, that I said that all of this functionality we can achieve with terminology service. So this is the definition from Fire specification, but basically it's a service that lets healthcare application dealing with terminology easily. For example, we can add this operation after the Firebase URL and send a GET request. I didn't talk about operation in this tutorial series, but basically it's a command that we can put at the end of the URL, and then we can request a server to do something for us. And there is a lot of operation in Fire like this. It's another way to interact with the server. There are some operations that dealing with terminology, and that is a terminology service. Lookup is for like a get information about the concept in a code system. Expand is like ask for a list of concept or of codes from a value set, and validate is like validate a code if it's in the code system or in a value set or not. So these are an example of terminology services. The last thing that I want to mention is canonical URL. Canonical URL is like a special kind of identifier that make it easy for other resource or even another server, another application to reference to that resource. What does it mean? Let's say that we came here to a patient resource. We have an identifier, right? A business identifier of this resource. But if we came here and we go to this code system, we will see that, okay, it has an identifier as well, but it has this URL thing inside that resource. This is the canonical URL, the canonical identifier that we can use to identify this resource quickly and easily. And canonical URL is the preferred way for referencing conformant resource and knowledge resource. Okay, I will not go deep in this thing. Conformant resource fit, for example, is that these terminology stuff and profiling and extension, all of them are conformant resource. It's a resource to tell that resource instance that we create is conform to particular specification or not. That is the conformant resource. And here is the URL element for specify the canonical URL. And this one, when other element refer to this resource, it will specify like this. Use canonical URL to identify. Okay, so now we will begin with the first resource in this group. That is a code system. As you can see in this screenshot, it may look complicated, but I would say it can be categorized into like this 4 groups. The first one is the canonical URL that I mentioned last slide, and the version of that code system, and some metadata, description, copyright, publication, and other metadata. The next one is some key characteristic. Maybe you already learned in another course about concept of terminology or vocabulary in healthcare. Concept like concept permanent, that is when the concept was defined, it will change or not in the future version. If it permanent like that, then it have the concept permanence. But if the next version came out and the concept changed, that it means that it doesn't have concept permanent. Hierarchy meaning like there are hierarchy or not. Compositional is like can it combine together to form another meaning? Like in SNOMED, right? There has a post coordinate and pre-coordinate. And if the code in that system is case sensitive or not. This is some key characteristic of that code system. And property, filter, and maybe some code system define a list of concepts inside that system. Okay, I would say you don't have to worry much about this slide, just listening to get some concept. Filter is like it's like when we define a value set, we have to include the code from the code system, right? Filter can be used in that situation. Property is like additional information about each concept. Like this concept is a child of another concept, or is a parent of another concept, or is not active anymore. So it's like a additional information for that concept to make it more complete. And for some code system, we can list all the code in that system as well. We use this concept element to list those concepts in the code system into this code system resource. So there will be a code, a display, a definition. Designation is like it's like a synonym or translation for that concept. And here is the example of the code system. Okay, we can see in the real thing. I think this one might be okay. Yeah. So this tells us that this is a code system, a URL, canonical URL, identifier, version, metadata, and this is some characteristic and filter. And this is the code inside this code system. So we have 3 code, this one, this code, and we display this to the user, and this is the actual definition, and there is like a synonym for this concept, like this one. In this case it uses as a internal label, maybe for communication internally. So that is an example of code system. You don't have to remember or create the code system by yourself. In this session, we will use a tool to create that. And here is the code system operation. This blue word is the operation, and this is an example. So if we want to get detail about the concept, we put the base, the type here, and put the operation and specify the system and the code and send to the server. The server will give back the detail about the concept. I will show you in the demo. Validate is to validate if this code and this test is in this system or not. Subsume is testing if they have subsumption relationship or not. Subsumption is that one code is there is a child of another code, for example. So we will create a code system for service type in a hospital with the following information. This one, so we have 6 clinics, and here's the code, display, and description. For creating a code system, we will use a tool called Snapper from C0. So you came here and say C0 Snapper. Here you will find this Snapper, and you accept everything, and we bring it here. You came here to file code system, and you create a new one. The title, Blood Hospital Clinic, and then that's hospital service, and done. Okay. There are some required field. These are metadata. You don't have to fill in, but you can fill in if you want. False. No, nothing. Content complete. Okay, so this is the property and filter for basic. Don't have to deal with it. So code, maybe you can put it one by one, like this. Put it here, description here. And this is for property. If you want to use like which one is child of another one, but not in this case. Or you can import the CSV from this one. CSV. We have one row. This one is code. This one is display, and this one is description. And we import it. Then if you want to put additional metadata, you can put here. If you don't want to do anything, then finish, download. Like this. I already have a Heartbeat file running on my local machine, this one. So I will send the code we create a moment ago to this Heartbeat file server. Okay, let's open it here to see it first. This is what created from the Snapper, and this is the list of concepts that we have defined for our hospital clinic. So I will put it inside the body code system here, like create normal resort, and I will put it via JSON send here, and then it succeed. I got the ID here. Maybe I copy it. And this is the code system, the code inside the system. For. Okay. Like this for future reference. Okay. The next one is we will demo a code system operation like look up this one. So, okay, let's copy it here and then put it here. And the system of our code system is canonical URL. Put it here. And our code, let's say that we want to look up for S001 and we send a GET request. Yeah, we will get information about the code, the name, the display of this code. And the next one is we would like to validate the code. So the code system we got is 5354. So we validate code for, let's say, S001. And we send. Yeah, it's true. It's in this code system. And if we want to validate display as well, for 001 is this one. Send is still true. That is this code, and this display is in this system. But if I change to something like this, it will return false, unknown code. Yeah, because this code is in, but the display is not this one. So this is an example of validate. And that is the example of code system operation for Subsume, because we only have one code system, so we cannot test it. Okay, finish the first resource. The next resource is value set. Structure of value set is quite similar to code system in many ways. It has the identifying URL, the canonical and version, and other metadata. The important one is compose. I think this is the most important. Compose it for defining the inclusion and exclusion criteria, because value set was created from, we bring a code from a code system to form a value set, right? So we have to have some criteria for selecting codes from code system. And expansion, we use it for customize a response to the expand operation when we request a server to expand the value set. And here is compose. We can compose a value set from a code system or from other value set. There are include and exclude inside the compose element, and we can have multiple include and multiple exclude. It will process separately. It will include first and then exclude out. And there are two ways to include or exclude. The first one is we list the code manually, and the second one is we define the filter element to programmatically select the code from code system based from this property. If we come here and we see the value set structure, we see something like this. The metadata, the URL, the version, and here is the compose. There are two ways of composing. Concept is selecting it one by one, and filter is selecting based on property. So this one is using the concept to list all the code like this, and this is using the filter property. This means that this value set include all the code that the parent are this code from Lloyd code system, and then exclude this concept out from the value set. So that is compose. And we also have an operation for value set as well. Expand is like expand the code system with some criteria. Get the list of codes inside that value set by that criteria. And validate code is like validate code in code system, but this is validate if it in a value set or not. One thing to remark is that if you want to use the expand operation in your local Happy JPA server, you have to enable the hibernate.search on this file before. Otherwise, you will not be able to use this. And there is a concept called implicit value set for some famous code system like SnomeCT and Lloyd. You can use a URL structure to compose a value set without defining the value set resource. What do I mean? For example, if you specify it like this, SnomeCT thing question mark file underscore vs, that is you get the value set that has all concept ID in this edition or version. If you put like this and equal is slash the ID, it means that get a value set that has all concept ID that are children of that concept. This one. And this one means that get all concept in particular ref set. A ref set is quite similar to value set, but it's in SnomeCT world. More info on this page. There is a lot of info about this. Next is the demo for creating a value set from the previous code system that we create. We will create a value set for clinic. That is the focus of the hospital by selecting only 4 clinics to form a value set. So this one, we will go back to Snapper, and then we will create the value set hospital based service, and then like this one, based service. It show again because I just did it before I record this video. Done. So other thing is pretty the same as code system. The metadata is quite the same. The difference is this one, the include and exclude thing. Include used for include code from the system exclude used to exclude code out from the value set. So include code, it include code by code. Include filter, it use the filter to include from properties. So let's say that we want to include Blood Hospital, and then this is the code system. Okay, so we will have this one, bring it here, this one, and this one, and this one. 1, 2, 3, 4, right? We already bring it here, and then additional metadata, don't need. It's strange that it doesn't get the display. Additional metadata, don't need. Okay, then we download the value set here. So if we open it, bring all. Okay, somehow the text here doesn't come with us. Alright, maybe I import the code system again. This one is code display, and I forget to delete, and then these two delete. So yeah, that is, and we don't need any metadata now. And here is the download value set. Yes. All right. And we get this. We open it here, and we will send it to our local server like this. Post send. Oh, error. All right. So I already created. So I have to 02 again. Okay, and I got this. Yeah, I created before this. I record the video, so it crashed, and I have to change the URL here as well. Yeah, but that is. So that is, we successfully create the value set. The next one is, I will show you how to create a value set from Sonomet CT, from like a standard code that had a lot of code inside that. Now we will use filter. I will create a value set from Sonomet CT that is the children of this one concept, healthcare service. Okay, if you go to the browser here and you search for the concept, you will find it here. It's a healthcare service and have 84 children. And each children might have children and children. So I think the descendant is might be more than 84 concept inside. Okay, so how to create that? We will go here and we will this one and this one 02 done, and we will include with filter, and we will include Sonomet code. There's a lot of version of Sonomet. I think I can leave it blank, and I will define it with the concept is and specify the ID like this. No additional data need, and we get the value set. Yes, save. We will copy it here and send to our local happy file. Send, and we got this. All right, but we will not be able to do anything with this because in our local happy file we don't have a SNOMED code in it. So if I want to demo the expand operation, okay, let's expand the one we have first, right? And expand this one, get. Okay, we will have the expansion element, and we will get the concept, but it's basically the concept that we define because we don't define any expansion things. But for SNOMED, if we want to test this functionality, we have to go to Onto server from C0, the one who developed this tool, and we will demo and expand operation on this concept. And you remember this thing, implicit value set. We can define the value set by just the structure of the URL. No need to create the actual value set. So we specify the URL like this, ISA, and this SNOMED CT ID like this, and we send to a server, and we get response. If we put show here, we will see that we get all the code that are the child, the children, the descendant of this particular SNOMED CT ID. This ID have 84 children, but many children will have children. In total, there is 410 concepts that are subsumed by this one. What is this one? By this SNOMED CT ID. So that is how to expand operation. I hope you get an idea of the expand operation. In case there are other code system that we define some filter, we will get a response like this, a list of a code that match that particular criteria. So that is expand operation. And validate code is basically is like in the code system. Okay, so that is the value set resource. The last resource in this group is concept map. Structure of concept map is basically quite similar to code system and value set. The other thing is it will specify the source value set and target value set. And this group element is for the actual mapping that happened. The mapping, the equivalent of the mapping, is it equivalent or something is bigger than another thing? For example, an unmapped is what to deal with when we cannot map. So here is example of concept map. They map this code from the source system to this code in the target system. This is from this one. Or maybe we can check it out. So it mapping between yeah, this source system address used to this v3 address used, and there are this one, for example, the code temp from the source. The source system is this to the target. It can map like a equivalent, so this is exactly the same meaning between them. And there are some resource that is quite not equivalent, doesn't need to care about it now. And there is an unmapped element to tell us what to do when we cannot map the code. So that is the structure of concept map. And concept map also have operation. Translate is translate code from one value to another. And closure is, I got this definition from Dr. Jim again. Mainly it's like testing a lot of concept for subsumption relationship. Okay, so let's create a concept map between our local code and the SNOMED CT concept like this. So we go back to our snapper and we will create the service mapping. Service SNOMED again 02. Then so we have to specify the source. The source is at hospital clinic, and the target is SNOMED CT like this, and we will select a code. Source and target, this one. Source, this one. Actually, this one we can import the CSV as well, but I think it's just 4 codes, so I copy one by one. I think that is, I forget to specify this thing, so I have to, can it show that? No, okay, I can copy it. Best service. And target is okay, so I have to map this to this one. Target value set this one. And validate. Okay, and I forget to specify the relationship as well. So all of this is the equivalent. Why can't I eat it? Okay. Upload, validate. Okay, download. CM. And I will open it. I have a source and target, and source system, target system, and the group of mapping here to here. Okay, I think it's gonna work. So I put it to my local concept map. Resource, post, send, succeed. The next one is trying to translate. Okay, let's say we want to translate between our system. Our system is this source system, and our code, let's say this one, and our code like this one. If I send it like this, it will match the Sonomet CT concept that I already mapping back to me. Yeah. I can also specify the sort value set like this. Like this. And we can specify the target value set as well. Target is this one, send, and it also work. So this is how translate work. And that is the demo of concept map. All right, so we finished this session. Okay, I know it's a little bit confused, but yeah, terminology is a big topic in I would say in health informatics. So yeah, I'm not an expert as well, but this is like a basic knowledge of working with terminology in FHIR. I really recommend you watching this video series. It's very great information about this terminology stuff on FHIR, right? But if you have any question about this, feel free to ask me in this video or in our class. I'm happy to answer if I can. All right, thank you very much for attending. See you again. Bye bye.